All right, starting lesson 2.6, bringing all the ideas together. We have an absolute value inequality here. All right, and now this is the important rule that you need to remember when working with absolute value inequalities. Less than, greater than. All right, now when you're working with less than, you want to think less than. All right, so and greater than, you want to think of greater than or. All right, so working with this absolute value inequality here, I'm working with an inequality. It's absolute value. So absolute value, you got two cases. All right, you got your positive case, and you have your negative case. And when I have the negative case, I have to flip the inequality sign. All right, now the most important part here is how you connect these two inequalities. All right, since I have the absolute value isolated here, I look at the sign, it's less than, so I go here less than, and they're going to be connected by an and. All right, and in a moment, you'll find out why that and is important. So let's solve these inequalities. All right, and now I'm going to graph them. So I have negative 9 is a smaller one, and it's greater than or equal to, so I'm going to the right. And then negative 5, less than or equal to, I'm going to the left. All right, now since the graphs are connected by an and, or the inequalities are connected by an and, I want to look at where the graphs overlap, and that will tell me what my solution is. So where do the graphs overlap here? Between negative 9 and negative 5, okay? So my solution starts at negative 9, and it ends at negative 5. X goes in the middle. Both inequalities point to the left, all right? They always point to the left. All right, so you could read this from right to left. X is greater than or equal to negative 9. And here, this part, X is also less than or equal to negative 5. That's our compound inequality. There's our answer. Done. All right, now going to part B. All right, going to do the same deal. 8x minus 11 is less than 0. 8x minus 11 is greater than, you could say negative 0, but there is no negative for 0. But we still have to look at the negative case. So we flip the sign. All right, then here, once again, I'm looking at the sign. It's less than. So I'm using and, once again, to connect the inequalities. All right, let's solve both of these. All right, we're going to get some fractions. Don't freak out. It's not the end of the world. Just take your time. All right, and then you have x is less than 1 3/8. Here you have x greater than 1 3/8. And once again, they're connected by an and. All right, so I graph these two. Let's see what happens here. All right, so for the first one, 1 3/8. It says less than. So open circle, going to the left. Then for the next one, it says greater than. Open circle, going to the right. Now, since I'm connecting these with an and, I'm looking at where the graphs overlap. And where do they overlap? Well, they don't really. You could say right here, but it's an open circle for both. So there is no overlap at all. So that means there's no solution for this absolute value inequality. All right, let's do a couple more examples. All right, for part A, I'm going to have c minus 1 is greater than or equal to 5. And c minus 1 is less than or equal to, then I'm going to have the opposite sign, negative 5. All right, once again, I have this rule here, less than, greater than. All right, think less than, then greater. All right, so here I'm starting off with a greater than, so I want to think or, connect them with an or. All right, let's solve both of these inequalities. All right, and I'm on a number line, -4. It's less than or equal to, so I'm going to the left. 6 greater than or equal to, I'm going to the right. Now, since I'm working with an OR, I'm concerned about everything that's covered by the graphs. All right, so my answer then is what's being covered by these graphs? Everything less than -4, and also everything greater than or equal to 6. And they're connected by an OR. So it's pretty much what we started with in the beginning here. But the solution would have been much different if we had an AND here, because then we'd want to look at where the graphs overlap, and they don't overlap, so your answer would be no solution in this case, if we're working with AND. But we're working with OR, so this is our answer. All right, going on to the next problem. I have 10 minus m is greater than or equal to -2. 10 minus m is less than or equal to, +2, right? Because we have to take the negative case, all right? And the absolute value is isolated here, so I look at the sign, and it's greater or equal to, so they'll be connected with an OR. And let's solve this now. So subtract 10, got -m is greater than or equal to -12, subtract 10, -m is less than or equal to -8. I'm going to divide by -1, flip the sign, divide by -1, flip the sign. All right, once again, they're connected with an OR. All right, so for the first one, 12 I start at, and it's less than or equal to, so I'm going to the left, then I have 8, and I'm going to go to the right. All right, now since I'm working with an OR, I'm concerned about everything that's covered by the graphs. Well, looking at the two of them, don't they cover everything on the number line? Yeah, they do. So your answer in this case is all real numbers. All right, because any number then is a solution to this inequality. All right, and then there's part C. I don't have much space here, so I'm going to bring it down. Let me rewrite part C on the bottom here. Okay, and this problem wraps up everything that you've learned this chapter. So if you could do this one, you should be able to do pretty much any problem. Okay, first thing you have to do before you do anything is isolate the absolute value. So we subtract 1. All right, next step is, once again, isolate the absolute value. So I got to get rid of the 4. Divide by 4. Okay, now I'm in good shape. All right, so this is the same type of problem we worked on in the past 4 examples. So I have to write out each case. Did I get farther? Okay, just making sure I didn't mess up here. Okay, and now, very important piece. I don't go back to the original problem and look at the inequality sign. I look at the inequality sign when I have the absolute value isolated. That's when I figure out what my inequality sign should be and how I connect the two inequalities. So it's greater than, so I'm going to connect these with an OR. So now I have -5, -5. Oh, this one's +5. Is that right? I know I was doing something wrong. That's add. There you go, 10. All right, so 2x is less than 10. And divide by 2. So here I have x is greater than 10. Here I have x is less than 10. And you know, this is a good mistake to learn from, because I knew something was a little off, or it felt off. And I realized that back here I had the negative case, and I didn't make it negative. Okay, so that would make this 0 here, which would make this result 0. And the math was off over here. I put 5 there. Okay, so we're in good shape now. Let's go ahead and graph these. All right, so at 0, I'm less than. Okay, we're going to the left. And then at 5, it's greater than, I'm going to the right. All right, now since I'm working with an OR, I'm just concerned about everything that's covered by these graphs. All right, so what's being covered? Everything less than 0 and everything greater than 5. All right, so it's x is less than 0, or x could be greater than 5. And that's your answer for this problem. All right, once again, watch out for those negatives, okay, because that often throws off students in algebra. Usually 90% of the mistakes are because of a negative. So just watch out for that. All right, we've brought all the ideas together now. Once again, I want to emphasize this idea of less than or less than, and then greater than or greater than for connecting the inequalities, because that determines what your solution is going to be at the very end once you're looking at your graphs. All right, that's all there is to it. If you have any questions, let me know. Begin the assignment on the bottom of the webpage.